series is a joint effort between the Internet Project and the Waterloo Institute for Health Informatics Research. Thank you for coming today. It's our last seminar of the series, Leadership in Health Informatics series. We're already planning the 2004-2005 series and have selected the theme, Emerging Solutions, Health Informatics Tools of the Future. The idea embodied in this theme is to have presentations on new, emerging, disruptive, innovative, and ingenious technologies, concepts, methods, and processes that have the potential for positively impacting our health system. I think this will be a really exciting seminar series, and I look forward to providing more details, speakers for the series later on this summer, early September. It's our delight to have Professor Kushniruk here today to speak to us. He hails from York University, and we're just really excited to have you here. Dominic, do you want to introduce our speaker?
I've known of Andre long before I've known Andre, so it's I'm glad you could come here. When you talk about ingenious technologies, I think some of the things you'll show us today, what we could do is get double duty for this, Shirley. We can have, he's the first seminar for next year as well as the last one for this year. Andre is an associate professor and director of the Information Technology program at York University. His expertise is in the areas of system evaluation and the human-computer interaction, which is really where I've learned most about him in the healthcare environment. He's done a very ingenious thing. I've seen the work is being able to use video technology remotely for assessing the way a person uses a system and measuring actually how that usage moves forward. Recently, he's been appointed as the new director, and we congratulate him on this, the new director of the School of Health Information Science at the University of Victoria. His background is in areas as diverse as psychology, biology, computer science, and cognitive science. So we welcome you, Andre, and look forward to your presentation. Thank you.
Okay, thanks. And feel free to interrupt me as I'm going along. So my title was Human-Computer Interaction in Health Informatics, from Laboratory Usability Testing to Televaluation of Web-Based Information Systems. What I want to do is go over, I'm going to start off with some of the early projects I did and see how they lead in eventually to what I'm currently been doing in the last year. So I'll be starting sort of with some background and then through a series of projects I've worked on. The motivation of my work is the following, is that there's a lot of problems with information systems in healthcare. If you've worked at all with patient record systems in hospitals, you know that there's a large problem of lack of acceptance of systems, a really poor usability in many cases. Often the systems don't take into account work practices. And another point I had there was introduction of errors. Currently, they're touting patient record systems as a solution to medical errors, and I'll show you in my work it's shown basically systems vary. One system might prevent errors, others could introduce new errors completely, which is another area I've got into. I won't get into this talk on errors in patient records. So at any rate, I said at the bottom there, issues related to human-computer interaction may be the single most important barrier to successful implementation of systems in healthcare. That's arguable. What I'd like to do is just as a framework to talk about a continuum of studies. I've sort of grouped the things I've worked on a continuum ranging at the left-hand side from what I call laboratory type of studies and the right-hand side what I call naturalistic studies. And we'll see examples of all of that today in the lecture. The laboratory studies often involve something known as a fixed usability lab. People come in, they use a system in an artificial environment. It's like an experiment. I'll show you some examples I've done of that in earlier work where we have people think aloud while using the system and we record what they're doing. And it's usually based around something called cognitive task analysis I'll talk about. In the middle is something called simulations. Simulations, at least the way I've used them, are simulating real situations like having a doctor interacting with a simulated patient while using a system. So it's that kind of simulations for evaluation. On the right-hand side, I have things that are naturalistic recording of people using systems. At the end of the talk, I'll mention about my current work on something called the Virtual Usability Lab, where I'm monitoring and recording many different aspects of computer use remotely, and data mining of it, which I'm getting into now. I just want to say that sometimes in some of the projects I've worked on, I've started in the laboratory side with the hypothesis about a system from a test, an artificial case, and then maybe moved on to trying to collect data in the hospital to confirm that. And then that data then has sometimes caused me to go back to the lab. So I look at it as a fluid continuum. A background for the work, evaluation in health informatics. When I started, there was a lot of what was known as summative evaluation. If you know evaluation jargon, that means evaluation of completed systems. Things like doing clinical controlled trials, you have a complete system, you put it in the hospital, you want to see if it increases medications or decreases. So there's been a lot of that. What I focused on a lot is on what's known as formative evaluation. That is evaluation in the design cycle with the intent of improving the product, so it's not a completed product. And I won't get into systems analysis here too much, but just one thing to note, that if you've studied systems analysis, you know that there's a traditional approach to system development called the waterfall methodology, where you have fixed stages and you go through requirements gathering, design, implementation, and testing. And that's still used a lot, unfortunately, in healthcare industry in developing systems. There's often little user input except at the beginning when you get the requirements. And then you go into the programming and design and then come back near the end, almost like summative testing, doing beta testing, for example. What I've been working with, you'll see in most of the projects I've worked with, are mostly with groups that are much more into the alternative approach, which is rapid prototyping. Providing evaluation in the design cycle, in the middle of it, perhaps several cycles before a product is released, where we start off by gathering requirements for a system, do quick design, build prototypes, evaluate using usability testing, cycle through, and eventually drop out. You can plan how many cycles, or you may just run it through until you run out of time. But at least you've always got the user inside the cycle. So before I get into talking about usability, what is usability? I'm working on more precise definitions, but in general, one thing you could say, it's ease of use of a system. And I like to think of it as a broad perspective. Ease of use of learning how to use a system is an important factor. What's the learnability of something like a patient record system? How effective is the system? 3 E's: effectiveness, efficiency, and enjoyability. If the system is effective and efficient but very painful to use, it gets turned off. And also I include in that safety as a sub-factor within usability. And I've already mentioned the importance of usability in healthcare is that we have problems of system acceptance, deployment, systems introducing errors, not reducing errors. And we also need methods in order, if we're doing that prototyping cycle, to provide input on each cycle, which is where some of this usability will come into. So usability engineering, I've borrowed a lot from work that was done in software engineering in the area of usability engineering. If you've heard this term before, it's, I think it was coined by Jacob Nielsen. There's a book, 1993, on usability engineering. There are several different streams to usability engineering. The first one I'll talk a lot about today with examples is usability testing. It's a simple idea. If you have a product, you have representative users testing it, doing representative tasks. And you record the process of use and analyze it. So if you're developing a word processor for secretaries, you select representative word processing tasks, and a consulting company might bring in 5 or 10 representative secretaries and have them sit down, use the system, video record the process. Another method is called usability inspection, where the users aren't recorded, but an analyst goes through using guidelines and principles to analyze the interface and make predictions about what the users might have as problems. So you might do this first and then go to usability testing to check it. At any rate, at least the way I've looked at them is in the framework of what's known as cognitive task analysis, is that it's process-centered. When you're doing these, even the inspection or testing, it's always in the context of carrying out a specific task. And there's a focus often on not just what they do on the computer screen, but also mental operations. And then I'll get into some examples in a minute. Just to say that I've worked on a number of different applications in trying out different methods. And these are some of them, and I'll mention some today. A lot of work initially with patient record systems. I'll show you the first one actually was an educational / decision support system. The latter half of the talk, I'll talk about how I moved into looking at web-based information resources. One example was a patient clinical information system, and then moving on into, at the end of the talk, about new work I'm doing in data mining. So I'd like to just start with, this was just the very first project I'd ever worked on along these lines. And it was a project that was in MedInfo 95. We ended up publishing that, but we did it before that. And the question was, how effective is the interface and content of a decision support tool? It was a CDI, which is like a little CD-ROM you can plug into a TV set, that a drug company was going to give out for continuing education to doctors and medical students. So we started video recording at that point to see how we could set up studies. And so we had 4 doctors come in and 4 medical students come in, gave them the CD like it was a real CD delivered in the mail, and had them think aloud while using the system and screen captured. Often with screen capturing, I'll mention that I'll have a PC to video recorder, a PC to video converter that will convert the screen from the computer into the video end of a VCR, and a microphone into a mixer in the audio end. There's actually simpler ways to record. I'm currently using something called HyperCam, which is a $60 program that records the screens directly, and then the microphone goes overlaid on top of it. But I'll talk about that in a minute. And analysis at that point worked on developing different types of coding schemes for analyzing video data. And I've used some that I'll mention here, and I'm just working on a long paper on just the coding aspect of it currently. So we developed coding schemes to code the data for things like problems and errors in using a system, aspects of reasoning and decision making, and the relation between the two. And I'll show you some examples to explain this in a minute. The coding categories that were developed then, I've since used almost the same categories with variations for a lot of projects since then. I'm currently working on one looking at usability of guidelines. And all we did was modify some of these categories. Now, the categories are things like about content. If someone's using a system, is the content appropriate? Is it too much, not enough? Is it out of date? And for medical applications, that's an important area of usability. I've seen projects on usability in healthcare where they just focus on the ergonomics of whether they can open the window and then leave out the aspect of the content. It's great to have a user-friendly system, but if the doctor says the information is useless, they'll turn it off. Comprehension, I have categories. The categories are defined, and I'll talk about them in a minute, for things like graphics, text, audio problems, synchronization. Navigation, for example, the category navigation is defined if someone comments or has an issue dealing with the ability to move forward or backward. Things like system understandability, understandability of icons, consistency of operations, even things like system crashes. We can come up with a sort of it's like an ontology or taxonomy of codes dealing with human-computer interaction. For coding video, I'll show you how in a minute. These were sort of cannibalized from questionnaire questions that were in the HCI literature, and I converted those into categories that you could use for categorizing qualitative data. Another aspect of this coding scheme is it's open-ended. Not only at one end can you code for things like user actions like scrolling, in interactions with someone with a system, like a doctor, we can code for aspects of reasoning in the same session. So if someone's thinking aloud, they may be thinking about the interface, but they also may be thinking about a diagnosis. So we can record things like considering a hypothesis, or if they're interviewing a patient, every time they request information. So to show you an example, this was actually the very, very first study that I worked on with this. This is actually a log file that I have on this was on a Macintosh computer. I was using a simple tool then that when I played the videotape back, this would connect to the videotape, and I could mark up and code the videotape. So you have the numbers there, actually the video counters, and we can go through, we have it transcribed. You can control the VCR with the keyboard and then drop in codes. Like, for example, the subject begins with, "I've already had to loosen my tie." We coded in, shifts in his seat. Then you can say where he goes to. He goes to the risk analysis guideline part of that program. If I had it connected here, I'd click on the number and it would automatically go to that frame. And then he says, "My first comment is 88 is a little old. I don't know if this has been updated." Now, this particular program that a drug company had made, we were testing it in 93, and all the guidelines changed in 90, and all the information was based on 88. So we had 4 doctors, and all 4 of them picked up on that. So that was coded as a comment critiquing the content in terms of how recent it was. The user clicks through different parts of the system. He eventually says, how do I fast forward? So using that qualitative coding scheme, that's coded as navigation problem. And you can even put the precise timing on this so that you get statistics on 3 out of 4 users when they go into the module, what problems do they have. He says, is there no way out of this? You can kill it. The experimenter this stops the explanation. He moves on. Eventually, the program crashed. And this was interesting. As the very first program I ever tested, they wanted to release this. They wanted me basically to do summative evaluation. And it was a disaster. They spent $70,000 on the product. They needed to fix things. They released it, and it was recalled. And then he goes back into saying 88 recommendations. My first impression, this was old. Things have changed a lot. I'd probably turn it off. He has other problems with it. Can't find something on the options menu. And at the end just says, now I have to get out the owner's manual. But it was supposed to be easy to use without any instructions. So that was the very first project I did along these lines. And what I worked on also was comparing the information you got from the video to standard questionnaire data on usability. Usability questionnaires are usually Likert scales where they have statements. And this is often the state of art when someone says they tested with users. They have them use the system and give them a questionnaire after. Or another one they'll talk about is giving them having a focus group of users. I won't get into that, but there's a lot of limitations. In this case, I just had what they had stated, that same user for the statement, I found the program easy to use. He said, agree somewhat. It was fairly easy to learn, agree somewhat. The content of the program is presented clearly, agree completely, which was, I had written something else later on limitations of questionnaires, is that you can't get any emergent thing from a questionnaire. You presuppose what you're going to look for. I never thought to look at, is the information out of date, for example, etc. So the user's perceptions often don't agree with what you capture on video. It could be other reasons. People often forget what they do when you ask them afterwards. So I got into the idea of multiple methods required for doing analysis. That led into another series of studies that was in MD Computing and JAMIA on looking at patient record systems. And we looked at a few of them, looking at going from people learning from paper, going to patient record systems. We even had some people in conditions going back to paper after to see whether the computer changed what they did or not in terms of styles. And we observed people using the system. And this particular system, I'll show it on the next slide. In the experiment, we were experimenting with different methods, like asking doctors to think aloud while entering cases from paper, or also conducting an interview with someone playing the part of a patient, which is what I term simulated patient. It was a takeoff of the standardized patient in medical education. Video recording the sessions. This study initially was done at McGill, and I'm since working on another one on the medical order entry system at UHN in Toronto, a similar idea, following over time, where in some cases we followed novices before they used the system and had them interview the simulated patient to get a baseline on how they normally interacted before they brought the computer in. And we also did analysis of asking them to do for the same records on paper and on the computer. So there's a whole series of studies. And this was that particular system, the first patient record system that was looked at using this approach. And it's very much like a paper scroll approach. It had all these categories. If you were the doctor, you would click on condition, click on something, open it up, fill in something following down. You could also draw a picture in there. So it was sort of one of those types of interfaces. It wasn't really menu-based. It was more like a scrolling kind of thing. And you have to open and close categories or the screen would get all cluttered. So that was a commercial product, the first one we looked at. And this was back in '96 where we were videotaping the subject, that's someone playing the patient. It's actually my former supervisor. And we would just video record them using the system. But actually, I've since done that on some commercial projects where they wanted to know how the patient system was being used with the patient. So I didn't stand in the room anymore, usually using a PC to video converter to directly convert the screen to the video, and the audio is the dialogue. And you get ethics approval for doing that, of course, but there's nobody standing there recording you. So that was kind of an extension of the procedure to looking at it in a simulated environment. We also looked at a study of introduction of that system in a diabetes clinic with interviews of people before they got the system. We followed their training, did some usability study of some subset, and followed them over time. And this is a similar paradigm I'm using for a study I'm doing now on order entry system at the UHN. logging all system use, and we also threw in some study of contents of paper versus computer records. So it was multiple different studies within that study. The results of that work was that for that particular system, we found that there was more what we termed irrelevant information in paper records that they did, matched records. What we meant by irrelevant was not directly relevant to the primary diagnosis. So it might be not the right term, because it actually might have been very relevant, but they just stick to information very close to the diagnosis. This I've found in many studies I've worked on since then, that overall, if you compare records that people do on paper on the computer, I've generally found about 25% less information in the computer version. Like if you ask doctors to do a paper version or computer or counterbalance it. So there's generally information missing. But what I wanted to show is how the actual interface will affect what information is recorded drastically. For example, on this system, there were fewer diagnoses recorded in the patient record system, typically only a single primary diagnosis. It was used in a diabetes clinic, and the system focused you on the primary diagnosis, so often they wouldn't put things about the heart condition, just because the interface got you into the mode of focusing down on the primary. So it was really quite drastic. And on this study, we saw some effects of different types of interfaces. For this interface, the users would often go from what we called hypothesis-driven, where they'd follow their own order. And the effect of that particular interface was they moved to something called screen-driven, we called it. What we mean by screen-driven was, for this interface, they struggled a lot with trying to find out where's the information about the question they wanted to ask. Maybe they didn't want to ask about this, it's somewhere else in their knowledge base. They didn't really have good search facilities. Eventually, if they liked using the system, you could watch them on a videotape following the order of the questions on the screen, which therefore changed the order of information they asked for, changed their diagnosis. So it was quite an interesting impact on that study. So that basically just showed that the interface could have an impact on their actual diagnostic process. Not that all systems have that effect, but this was an example of an effect that was kind of profound. And we looked at that in terms of saying that when they were using paper, they were directed by the data. They would ask a question, go to some other question based on the answer to that, all over their own knowledge base. With the patient record system, this particular one usually locked you into a diagnosis, because it would say, what's your chief complaint? And then after that, slightly change the format of the information. And then it's hard to go back after and change that. And we asked them afterwards to go back to paper, and a lot of them actually still drew out on paper the format of the computer. So they were kind of affected by it. So that was looked like, we didn't look at it very long, but a semi-lasting effect of the use of the system. We did a whole series of studies on this. There was an MD Computing and JAMIA. Also, sort of within there, we asked doctors for several records to do them both in the handwritten and the computer as equivalently as possible, and then coded them for actual components of information in a patient record system on the left. This is typical information units. And we found that for the same records, for example, there were many more units in the patient record system of information about the chief complaint, because that interface actually had a lot of fine-grained subcategories. So because of the interface, it drew the user to filling that out. On the other hand, other categories actually decreased in how much information was recorded, like history of present illness, to do with the interface. So it's not to say that all systems are like this. It was to demonstrate that even the slightest change in the order of the interface would have an effect on what's recorded. But in general, this 25% reduction generally held overall. So that's the kind of thing we were looking at, and started working with designers of systems at that point, because the interface obviously had an impact. And this was just to show that in the paper, people would go from patient data towards many hypotheses. With the patient record system, they'd usually lock into fewer and then go backward to data to confirm it. That was a difference. I won't get into that one. Also, in that series of studies, started looking at, can we log or qualitatively analyze not just the user thinking aloud, but the interaction with the patient, or extending out in recent work I'm doing, interaction with multiple people or agents. So how do you log that? So it's the same kind of thing. We have a log file with the counter times here, and then you can, at a more macro level, say what the doctor's doing. Is he creating a patient visit? In this case, he starts to select that filter for the chief complaint, stops, and then starts gathering without the computer on paper. and then eventually goes in and just follows the categories on the screen. So this was an experienced user, and when we interviewed him after, he said he kind of knew it locked him in, and he liked the system, but he wanted to interview on paper first. This is a study where we videotape both the screens and the user interaction because you wanted to see what he was using on the desk. So this was sort of an extension of that. So we're kind of moving out from the individual to semi-real situations to groups. Questions at that point? Yes?
I was curious. The psychological profile shows 10 on paper and 11 on computer. That kind of intuitively doesn't sound the way to go through the psychological profile. I was wondering what questions we...
Well, it's just that when we coded it, they may have had, the designers, when they had categories where they really did a good job in defining subcategories, people tended to fill those out. So that was one where there was equal, pretty well equal? Yeah, so that one had probably about the same number of categories as people normally were filling out. Some other ones, it almost seemed like in the design of the interface where they sort of shortened the number of categories possible, those ones were likely candidates where they might fill in very little, whereas on paper they might fill in a lot. So it was really sensitive to the design of the interface. Yes? Oh, sorry, yes.
That overall 25% reduction, is that mostly what? Because I know a lot of times, like physiotherapists, occupational therapists, and even nurses, when they do narrative notes, or physicians, they're kind of chatty in them. You know, when they their family and brother and two stories. You know what I mean? That kind of
so the question is the 25% loss that typically find with the patient records fluff or not? Well, there's a lot of people that have done more work on actually the straight comparison of paper to computer, and a lot of those people have looked at the aspect of the narratives, what's in the narrative, and connecting things that might provide information that you lose when you make it discrete. And one of the projects I'm doing now is having doctors use computer patient record and handwritten, and then hand them to another doctor who doesn't know anything about it, and compare the story about that patient from the person who wrote it to the readers. Because I think that you with not only the screen, but when you have the output of a patient record softened in categories, you may be losing all the connecting material about the story. And furthermore, most patient records I've ever seen, and I've written a paper with Jose on something related to this, don't contain any, they're physician-centered, don't even contain categories about patients, like the patient's understanding of their illness or compliance. So I think there's a lot there in the information that may be lost in the apparently irrelevant information, may not be so irrelevant.
So it wouldn't be affecting decisions, though, like if they're giving us to the consultants, would that consultant...
Well, that's one of the, in that study I'm doing now, I'm looking at is what the decision that the writer would have versus the reader if they're just given the printout at the end of it all. Yes?
Does type of input affect whether information is lost or not? For instance, if people type comparing to using a tablet to... Oh,
lost as in not recorded or not looked at? I haven't done studies comparing like tablet and that, but I mean I've looked at some where I looked at voice input on a patient record system, and there were technical issues on that one. Obviously when you got into clinic and that, there were a lot of loss of information just from the background noise interfering with it. So from the technical point of view, in that kind of situation, I've seen a loss of information as well. Okay. What I want to do is then move on to how I got involved in looking at use of systems on the World Wide Web, and then how I got into one that I worked on with Columbia, and then how I got into the current things I'm doing on tracking web. So the objective of this whole thing was to adapt usability testing to the World Wide Web, to ask questions about how are people using healthcare sites, did they get the information they want from sites, do they have problems. First studies I've looked at, I'm back to looking at these now, web-based guidelines, how are they used. And I was interested in remote tracking of web users, and to some extent to see what extent could you push things like remote video analysis and some other things I'll show you in a minute that are a bit experimental. Evaluating usability of web-based healthcare information systems, this has been more of what I've worked on the last few years. You have issues of varied users interacting from varied locations, so you're less able to do controlled studies like what I called the lab studies before. What's the current state of the art is that a lot of people are doing studies and marketing and other places where they track user actions, clicks. You can get a lot of information about clicks, but then you have to do a lot of stats on it. But the one thing I found out from pure track logging is that it tells you what someone does, but just like the other forms of data, often it doesn't tell you why. So I'm looking at methods of getting at interrelating logging data to other data. Online questionnaires or feedback forms, if you've used a website, you're going to get a biased sample of people who fill it out, either people that really liked it or hate it, and I've never filled one out, so they're not really a very good form of evaluation. And if you interview people, like focus groups or one-on-one interviews after using a system, you get the same old problem of people often not knowing what they do after the fact. So I want to get information right at point of use. So questions are, what type of information do we health consumers want? Is the information useful or helpful? So similar questions to the artificial lab studies, but now the limitation of trying to get this data from the web. How do you collect useful data from large numbers of subjects remotely, which is my current research, and integrating the data from multiple sources, and being able to analyze the data from all that data to discover usage patterns? So the objectives, I said, were to collect psychologically rich and useful data on a large scale, wanting methods for automatically collecting usability of data at the point of care, like if a doctor is using a guideline on the web, to try to get data right at that point. To identify patterns of usage right at the point of care, to automatically maybe probe them right on the spot at that point to collect further data. Also, to come up with tools for identifying patterns of usage from the merge of the different types of collected data. So I want integration of multi-method data collection analysis to answer both specific and generic questions regarding use and usability of health systems. The evaluation methods, an integrative approach, usually in doing these studies, when they first log on a system under study, I do use questionnaires. I find questionnaires are good for things like asking what your age is. That makes sense. If you're asking somebody about usability, it doesn't seem to work. But if it's online and it's the first time they log on a system, you can keep, I'll show you how I do this. I keep a profile of what they're clicking on, a whole history of what they're doing. On first login, you may bring up a questionnaire about their demographics. Who are they? If you're allowed to ask what type of disease categories they're interested in. And then I also worked out some other kinds of questionnaires that can be triggered to appear at point of use triggered by browsing patterns. So it's hard to say, how would you tell whether clinical guidelines are useful for physicians? There's a lot of debate. Some people treat it like, yes, they're useful. Others say it's not useful. So wanted a way of sort of saying, can I pop up something right at that point when they go there and ask them, did they get what they want? So this was from the initial approach to this. I'll show you the newer way I'm doing it shortly. This was from a study that did at Columbia, where we had doctors go from an information page where they could click on a guideline, and instead of going directly to the guideline, we wanted to know why they were going there. You could pop up a little thing to say, why are you doing this? For help care for a patient or for general knowledge. You have to make this quite short, because people have said if you do that too much, then you're going to affect the usability. And on a grant, somebody said that, but I since worked on a project there where I do a baseline of those users to see how often they go to the site, and then pop this up and see if there's a change. If there isn't a change, then I do get useful information, I would argue, about why they were going in. Or on entry, exit, did they get what they want? So they do that, and then they go in, and then I started collecting data on the log of what they're clicking on. So I can relate the log data to questions about why were they going in, or did they get what they want. That was one example of interrelating different types of data. Other types of data, in the studies I'm doing, I collect log files of all interactions, all functions and buttons clicked on. So I still do log files. They're very useful, but as I said, not alone. Interviews, conducting interviews over the phone initially, and then trying to move towards electronically mediated conversations, a little bit more than just questionnaires where there's more of an interaction automated between the user and the computer about what they're doing. And also working on other studies I'm doing, which I won't talk about, looking at pushing usability testing with recordings remotely over the web. So looking at different types of low-resolution screen recordings of people using information systems, and actually found a good source of software for that in spy programs that employees use to monitor their own. I mean, I always do this with ethics, but you can use that technology. So it keeps a recording without swamping the computer of all the things they're clicking on. It just does a low res, and then only when you move the cursor does it do anything. The other screen recording programs I've been using, this HyperCam and and if you don't have a lot of memory or disk space, it'll swamp it very quickly. So looking at to what extent can you collect remotely video data. So overall, the different types of data, and I'll talk about how I'm putting this together in something called the Virtual Usability Lab. Video-based data, moving from laboratory to remote. Interviews, moving from the phone to electronic. Email, users usually can email. They interact with the system, consumer information system. Always collect log files, and I'll talk about how I worked on something that's a remote log file tracker that you don't even have to go to the site to plug it in. You can do the tracking remotely. And also these other kinds of data about specific triggered things. So always looking for different types of data, and I'll talk about how I'm trying to put all these together in integrated databases for querying. But before I do that, the idea that I got for this came from a project I worked on, which wasn't really automated, but you can see where the pieces came together for what I'm doing. So I'll talk about this first. It was a system called Patient Clinical Information System at Columbia, and it was very experimental because over the World Wide Web, it let patients review their own medical data and lab results. So it was the same thing the physicians saw, and we let patients at home actually see what the physicians saw. There were security issues. They had to have secure ID cards and things like that. And it took about over a year to get ethics approval for it. But we had a small subset, and we followed them over a year. It was more than a year. They could enter their data, like blood glucose levels. There was even an advice function using guidelines to tell them whether to exercise more or not, with a disclaimer. And also, they could go to information buttons. And we didn't get a lot of users. There were about 20 users, but we followed them over a year, so there were hundreds of thousands of accesses. So at that point, I got interested in looking at issues of data mining, although this project wasn't data mining per se. This was that interface. It was a very nice interface, and it was based on a Columbia interface called WebSys, but they called it PATSys. They just took the physician's interface and made it for patients. And it was very nice. It was very web-based. There were only 4 or 5 buttons here. You can click on Data Review, go to Lab Results, and then you could see the data here. And actually, my first hypothesis was we didn't change it very much, so how on earth would somebody who's not a physician understand any of it? Well, that's an interesting question. When I get to the results, there was a huge impact of it, but not for all users. Because we didn't really sugarcoat anything. The subjects were all, I wouldn't say, they all had computers, and they mostly had college degrees, but not healthcare. There were help buttons, but people didn't seem to use them. So that was the idea, and we're following them over a year. So the question was, what features of such systems are most used by patients and why? What are least used? Again, interested in usability issues. How does use of such systems affect the doctor-patient interaction? Can the patients even comprehend information presented if they're non-biological or medically trained? And we didn't really get into this that much, but do these systems affect decision-making and disease management? So data collected included things like function usage from logging. So we did find that the review of laboratory data was used thousands of times, accessed by patients at least once in the majority of sessions. And not only patients, but even the patient's spouses and that would be accessing it. Some of them got really on top of their data, so to the extent you could say a patient could be an expert on the data, there were some patients that tracked it every day. They had more of an investment than the doctor, obviously. A review of reports. Other functions didn't get used. They didn't use the advice. When I ran this study, I was in Montreal, and they were doing it in New York. And the instructions were given from the doctor to the patient if they wanted to participate. And when I phoned, I said, well, did you show them how to use the advice function? And they said, not really, because it's web-based, you don't need to show too much. So I can't really comment about that, but it's sort of a mistake to say if you're going to give an advice function, some that knew about it said they weren't sure whether how to use it, so that was one thing. Education they didn't use, don't know why. Data entry they didn't use because when we cross information, we also interviewed the doctors, and they said they didn't take data that the patients entered, any of those doctors, so there's no point entering your blood glucose. But the main thing was this review was used a lot. I don't have the actual number of usage, but 93% of the times they went to review their data. So what came out of this project was that because I was sitting there looking at a lot of different types of data, pretty well manually, I was able to look at and say, okay, answer questions. Who is this used by most? And it actually came out, which makes sense, people with chronic illness. So because if someone has diabetes, they know all about their blood glucose. You don't have to train them very much to know that screen. It wasn't used as much for acute patients, obviously. They're not going to invest in learning how to use it. Patients liked the system since they felt greater ownership, and physicians liked it because they said it streamlined the visit and saved them time, because the patients then were armed with information they didn't have to explain to them. From the interviews with patients, the patients would say things like, communications is less in the way of getting information and more in the way of discussing treatment options and agreeing on a course of action. It's more efficient than the old way. And this was actually from a patient. I looked for trends in my medical data. If I see something, I contact the doctor to see what's going on, what we can do, change meds or whatever. The patient's almost sounding like a physician. The physicians, there were only 4 physicians, but they all said the same thing. Right now, most of the communication takes place during the 10 or 15-minute visit. I throw a lot of information at them about what to do. It's hard for them to absorb that. The system gives them a chance to go back and look at things about their health record they can then ask better questions about in the limited time. So that was one thing that came up. So we had a number of results. But for my current research, the main thing was that by interrelating things like the logging and other data, you could get at what was really going on. And most of that was semi-automated. So that I got interested in saying, from a study like that, for example, can you take all the different types of data we had, usage log data, online questionnaires that were baseline about demographics, these pattern-triggered questionnaires, electronic interview, other types of data, and automatically collect them into some kind of a database merge that you could then do ad hoc querying on or do pattern discovery on, which led to the current thing I'm doing, which is called the Virtual Usability Laboratory. And the objective here was to develop a software tool that would allow for automated tracking and collection of multiple forms of data, including log files, questionnaires, whatever. I'm always looking at different forms of data. We want to automatically store the information in a way that you can do ad hoc querying. Initially, I'll show you a very simple approach using a relational database. I've also worked a lot with object-oriented technology, so looking at an object-oriented approach to this as well. So you could do SQL queries about how users are using the system. Then you could say, for example, I wanted to automatically say what I derived manually. What type of users are using it? How often and what functions do they use? How old are they? What kind of illnesses do they have? So I could automatically query. And the other thing I wanted with this project is development of a user-friendly interface for researchers that allows them to set up a study without having to know all the details of how all the data is collected or it runs. So the components of this system developed a central tracking and data collection component, which allows the user, allows us, the evaluators, to track users of a system remotely. This was from a piece that I worked on initially in Montreal, and then extended it to a lot more, as you'll see in a minute. We want a system that can track users in city X accessing, say, guidelines in city Y. But instead of going from X to Y directly, they go through a server in an intermediate city. So by doing that, I can get what they're getting, get that information, return it. So I never, have to plug into that site to talk to the system people to get log files created. And I can also intercept things and look for patterns as they're clicking. So also, this component is responsible for collecting other forms of data, like questionnaires. So the user accesses a site not directly here, but going through the web server software that gets the request and then goes here. So if I'm evaluating a system, when they're going to this site, if that hospital or whatever allows me to actually transparently link through me, then I can see exactly what's going on. At this point, I can trigger things and say, why did you go into there, knowing what they're doing. And I can do any kind of logging I want here without going into the actual website to do the logging. So it's a remote logging. That was the beginning of the component. Then I started adding components. Presentation component for controlling the logging of users' interaction with system under study. This would be a component that would say, fire off a certain questionnaire after the 100th use of the system, or 100th time in a function, or after 6 months, for example. Have it pop up. It also maintains a profile on the user studied. Data storage component, want to rather than doing this manually, integrate all this data in a logical format. So storing data collected in appropriate, in the example I'll show here, relational database tables. One database table for user logging data, one for storing online questionnaire results, etc. So a simple example I just made up is, this would be a table containing information about, this would be a log file basically in a table. Log files usually have the person's ID, the time in, time out, the URL. So you have a table like this. You can link that by the user ID or time or some other key to something like user demographic information about user Joe, age, education, etc. And you can link that to other tables of information, maybe obtained from online questionnaires about their illness status. So by automatically being able to dump the data in these tables, you can do ad hoc queries, like asking about, for people with diabetes over 40, what type of function did they use in the system. Also, the other thing that this is a prototype at the moment, but it is working, was we also wanted to, and I'm working on this with physician Francis Ho, who's also going to be in Victoria. He's currently in Brampton at the moment. A researcher interface component that's designed for researchers and evaluators. So it lets the evaluator set up the parameters of all this without having to know the details. The evaluator would just provide the URL of the site that they want to be evaluated, the type of data they want collected, and type of, we'll also allow selection of whether they want graphs, other types of data. The results end up being displayed to evaluators and system usage, like graphs of function access, time spent in the system, number of user problems. But the main thing is it allows for what I wanted when I was doing those other projects manually. I wanted ad hoc querying of data, to be able to ask what are demographics of subjects who access a particular patient healthcare site or subcomponent. What is the work context of physicians accessing a set of guidelines? So to give you an idea, this is just a prototype, but it does work at the moment. This is the researcher's interface. The researcher would specify the URL of the site that they want to evaluate. In this case, it's my class website. And then at that point, they can specify options on what kind of log file they want. They can say, I want user ID, time in, time out. This is just a prototype, but we have variations where you can specify your own option for what you wanted added to the log within reason. Then it asks the researcher, do you want a background questionnaire to come up? And then there's other ones, when do you want it to come up? Right away on first invocation, 100 times, 6 months later. If they say, well, they said no there. If they said yes, there's a bank of built-in online questionnaires that we developed about things like demographics, computer background. If you click demographics, then you get some options, or you can create your own questions as well. And it'll be storing all this automatically. So you set up the parameters for your remote tracking. Also, in order to be able to do those pop-up questions, how would you have the user set that up? We don't want them to have to specify the URL. If the researcher is going through the site they want to evaluate, like my site, it says now you can go through pop-up questions. So they're clicking through my site, and then at that point they'd indicate, if they click on that link, they want to know something like, we'll ask, are you a registered student? And that'll get dumped in the database too. And all this is tracking without having to put anything in the system log file at my university. So they set that up, and this is just for a testing interface, but actually it would be transparent, because if someone allows you the link, instead of going to X guideline site, you really go through me for the purpose of the study, you wouldn't even see this. But here, the user's typing in, they're going to that site. When they log in, the questionnaire about demographic pops up, gets put into the database. If they click on this link here, just as we had triggered, the questionnaire comes up about, are you a registered student for the course? So what we're doing is setting up an interface, and I'm using this currently with a number of different projects. There's a current project I'm doing that's called SAGE, Simulation and Gaming. It's a project across Canada looking at how web-based role-playing games and things can be used for actually teaching healthcare to kids. And we're developing sort of a site for collecting evaluation data, including this and other tools, to collect data about individual projects in related databases, and also across projects across Canada. We're extending the idea. So the ongoing work I have here is the analysis and use of usability of web-based applications, moving to other areas, web-based patient record systems. I mentioned this one, the SHRC-funded project on simulation and gaming, just started. We're trying to set up a kind of an evaluation server that would be central to all the projects that are going on and collecting data, even relating data across projects using common database. And working on, I didn't get into today, I just started working on, had worked with some people doing data mining to look at possibilities for doing pattern discovery algorithms and data mining of stored data. But actually, compared to a lot of data mining that involves a lot of high-powered statistics, because you have heterogeneous databases that don't merge, my data mining is actually quite easy. If you can get things related on users, times, or illnesses, it's almost standard database. I can extend it with object-oriented, but it's not a problem. So that's sort of where I started off, and so I wanted to talk about where I came from, and also you'd asked me to talk about my current research, and that's sort of where it's heading. I still do both. I still do laboratory studies in conjunction with these remote studies. In fact, what I tend to do is results of that qualitative stuff I now have coded automatically and then put in a database that can then be, often it's web-based systems, interrelated to tracking data as well. So that's it.